Okay, well, we go ahead and calculate this, right? And we get this, which simplifies, I think, to this. And if it doesn't simplify this, it simplifies to something else that's equally unlike this. So what's wrong? Okay, so might be that there's some BS involved. Okay, but there really isn't, because I just made up these functions, okay, with no particular attention except to the fact that we're sine and cosine functions. To the possibility that this function could even occur as a result of this driving function under these conditions, okay? So what we conclude is that this function could not possibly have come from this function. Okay, now what's our conclusion? Well, presumably this function is something that we got from our observations, which means we probably mixed up data from 2 experiments, because we couldn't be that far off. Okay? So our conclusion, well, we'll put a big on there. Well, there's no guarantee okay, there's no guarantee that that output function could occur for the input function if the equation is ax double prime plus bx prime plus cx equals f, where x is an x of t, x is f of t, okay? If it does, then the output function, or the ratio of these Laplace transforms, has to be of this form, because we got this form by solving that general equation. Now I say of this form, with x of 0, x prime of 0 both equal to 0. Okay? Couldn't have happened. This means that if this is an experiment, we've really messed up our observations of f of t. Okay? So I say we either really messed up our input function, meaning that our input function wasn't what we thought it was, okay? Or failed to correctly observe and model the output of our system. Okay? Now, if I had wanted to guarantee a solution here, I wouldn't have just made these up on the fly off the top of my head. I'd have put a number for A, a number for B, a number for C, and solved the equation for this input function f of t. Would have been an easy solution, just a simple undetermined coefficients. Wouldn't have to even use variation of parameters to solve that equation, right? And then I could have gotten an output function and then asked you to rediscover it, which of course is what I'll do in a test. If I don't decide that I want to do this and ask you to interpret the result, which is that ain't no way. Or it might be, I might give you a problem with a 50-50 chance. 50% of the time it'll be an accurate solution. 50% of the time that problem might pop up with a solution that couldn't possibly be right. Okay? So let's go ahead and do one with an actual solution. We'll go ahead and solve a simple equation. Okay, we can do that in just a couple of minutes, and then see what the Laplace transforms are and see that the ratio is of this form, if we do everything correctly, which is always a question. Okay?